Good morning, everybody. It's a pleasure. I'm sorry I don't speak Spanish, and I don't think you want to hear Italian. It would be a little bit confusing. So I have to switch to English. Thank you. One first thing that I want to say is, so the first message is the one that you will not forget. Internet of Things is a strange animal, but will be strongly controlled by software. So software and softwareization that we will see later, it's the most important point if you want to realize the Internet of Things. Software will take over everything, and we need to be aware of how to do this. So we will go through a short agenda, IoT and things, what a things is, because we need to define somehow Internet of Things, the data that Internet of Things is producing, then IoT and communication, since I work in Telecom Italia, by the way, so we are quite interested in understanding how Internet of Things will use communication. And then a few remarks, a few suggestions, if you want. So the first thing that is important to see is the context in which we are operating. From the point of view of an operator, the world is totally changing in these days. Before we were buying from American telecom companies, we were buying equipment, now just European. The American industry in telecommunication has moved to something else. We just have Ericsson, Siemens, Nokia. That means something. We were buying systems. In the future, we will buy software, and what will be general purpose hardware. That is something quite interesting. You can have a new network, a totally new network, just buying general purpose software and putting maybe some open source on top of it. If you want to be more specific and you want to talk about Internet of Things, think to Arduino, Raspberry Pi. It's open hardware that is changing totally the way you design the things. And yesterday, during the session related to the smart cities, people were saying smart cities is not technology for technology. I tend to agree, but I just want to say also, if you don't choose the right technology, you are going to be in big trouble. And the second point is the makers, the availability of so much hardware, general purpose hardware, and general purpose software, open source, is changing totally the way you are doing things. You can imagine a general purpose hardware platform with a lot of sensors with open source on top of it. That could be the platform of the future. That is changing totally business perspective, how the people are using your stuff, how the people are developing services, how the data are collected. It's totally different. Then there is also the other aspect, virtualization. We are going to, since the general purpose hardware is so powerful, we are going to virtualize a lot of stuff. So we can migrate old stuff into new stuff, we can use better our resources. And then autonomics and self-organization. When we talk about Internet of Things, we are talking about plenty of different sensors, machines, aggregators, computers, or whatever. How are you going to manage all this stuff when you have millions of sensors in your smart city? You need them to self-organize. We have a red car in Telecom Italia with the person that is going there to do the maintenance. It's impossible to send these people around in all the cities to detect problems or to solve problems. So we need to move to something else that is strongly, it's a strong challenge from the technical perspective, autonomic computation. So softwareization. I don't think you are going anymore to travel agency. Probably when you plan a trip, you do that by software on the web. Probably you don't buy any more CDs, you just do something else with music. I think this kind of change is happening also in telecommunication. Probably a new operator can put in place a new network with 1/10 of the people that Telecom Italia has, and with higher quality. And maybe they can also have bigger networks than we have. We will see also big data and virtual continuum. Pay attention to big data. Big data, I see in this conference that Colombia is very much concerned on the user, on the citizen. Big data could be a good thing for the citizen, but could be also a nightmare if the data related to people are not treated in a fair way. We will see a little bit of this. Okay, so Internet of Things, what is it? We have two views on Internet of Things. A small system, we could have also millions of sensors, and bigger systems in which you have to deal with different administrative domain. That makes a big difference. Because on the first part, even if the system is complicated, you are in charge for everything. Think to your home, your security system in your home. Even if you put sensor all over the places in your home, it's still defined, confined, and you can manage. But think to a system of a smart city. Who is deploying the sensor? Who is making use of those? What are the administrative domains? And that is another reason for having autonomic computing. So we made a difference between the two definitions. There is a story behind this. When we started the IoT initiative within IEEE, we were saying, okay, we will get a definition of Internet of Things from the standardization bodies, and we will use it. There is no such a thing as a unique definition of Internet of Things. You will see later. So we prepare our own things. The Internet of Things envisions systems made out of network sensors and smart objects whose purpose is to measure, control, operate on an environment in such a way to make it intelligent, usable, programmable, and capable of providing useful services to humans. So have a look to measure. If we are talking about smart cities, once again, if you want a city to be smart, you have to take measures. You have to know what is going on in that city. And so you have to deploy sensors all over the place. And you have to manage all this infrastructure. We had a very strong experience in Venice. I don't know if you know the city in Italy. It's an uncommon city. It has been built on top of a lagoon. Everything is artificial. There is nothing done in nature there. The people were putting poles in the lagoon in order to create buildings. Well, we had the impression that if we can be able to solve problems of intelligent cities in Venice, we could solve problems all over the other cities in Italy and probably in Europe, because it's very near. There is a lot of water. The buildings are very old, and so we started a number of different small projects in order to measure the city, in order to collect the data of the city, and then to try to predict what is going on in the city. If you have been there in a specific day, you know that there is, I don't know if you have ever heard of one-way street for people, not for car. Because it's so crowded in certain period of time that if you want to do a special street on the other side, you cannot do that. People will walk on you. So it's really a particular city. So we took Arduino technologies, we put a few sensors in certain specific parts, and we were trying to measure the number of people that were passing by in order to advise the tourists, stop coming, choose another way. There is another story also behind this Venice stuff, just to describe to you the complexity of Internet of Things. All the people that are visiting Venice, they just want to go in one place, San Marco Square. And the city is so full of other things that you want to see, but you don't know. And so all the people are just going in one or two directions, and they do not see the other part of the city. So we were trying to understand how to involve people and visiting more of the city. So we were building an application with crowd sourcing things in which people were cooperating each other in order to say, there is too much people here, why don't you go to see this other stuff and things like that. So you see, an IoT system, when it's big, needs to cross different administrative domains and has to involve also the terminals of people. That is another important stuff. That means that a lot of intelligence is not in the cloud, if you want. It will be at the edges. It will be at the terminal stuff. So we need to understand how to create this cooperation between the network, the cloud, and the terminals. We will see this later. So IoT. IoT implies a lot of challenges. I'm an engineer, so I focus a lot on technical stuff. Then, since I'm a software engineer, if you ask me what is the biggest technical challenge, I would say software. But if I were a security expert, I would say in Internet of Things is security. So you can see the challenges, also the technical challenges, are important according to who you are or who you ask to. But there are plenty of different technical challenges. But that's not all. Yesterday, again, in the Smart City session, there were people that were saying, we need to invest a bit of money on infrastructure. Why? Who is going to do that? We operators are in such a situation in which we do not know if it's convenient to invest in fiber optical to the home, because the return of investment, at least in Italy, is totally uncertain. So we are talking about an investment. Yesterday, the Toronto representative was saying, we want to have the fastest network in North America. That's a lot of money. That's a lot of technology. And if you choose the wrong technology, it's a lot of wasted money. So you have to be extremely careful on what you do. So there is also, when you talk about Internet of Things, you have also to look at the businesses, the perspective that you are going to give in order to create businesses. And then there is another issue that we call society-related issue. And here it could be specific of the Italian people, it could be specific of Colombian, or it could be also general. We made a lot of interviews in Italy. We were saying, look, we are providing to you some security-related system for your home. Would you like to have it? And there were two important answers that the people were telling us. The first thing is they don't want to be involved. They are not engineers, and they don't want to be involved in implementing, managing stuff. They want to push a button and to have the system running. The other question was, would you share your information with the community? How much you consume, where you are at home? And they were saying, absolutely no. This is my home, and I don't want anybody to know what is going on in my family, essentially. So you see a lot of issues related to data. Do you want to share your data, what you are doing in your home? I don't think you want. So a lot of application that you have in mind should go through an understanding of what people are willing to do, what are willing to share. There is also something else that is the policy. Policy may have a strong influence on many technologies, but we are not going to deal with it. So we will see a bit of these technical challenges. So first of all, what things are? Well, essentially, we refer to a thing, to an object, with a bit of software that could manage to have an address, an IP address, let's say. And so it could be connected through the network. The idea is that the network could have a lot of importance. But as we are experienced as operator, network and connectivity is becoming a commodity. So there will be a huge usage of our connectivity, but the revenue will decrease. The more they use the connectivity, less revenue we will be generating in a way or the other. So things will be important, very, very important. Again, think to what is happening in the Arduino contest. You can buy processing equipment for 20 euros. You can buy Wi-Fi board for 2 euros. You can build a lot of intelligent systems, a lot of intelligent things with a very low price. A couple of years ago, I had a student from Brazil, and he was working on Internet of Things. And so he said, why don't you take me to see your labs, especially on e-health stuff? So I took him, and I was very proud, and say, look, we are developing a medical application here. And you see, we are buying the best sensors on the market, and that means 1,000 euros, something like this. He was watching me and would say, oh, I can do exactly the same stuff for 50 bucks because I can use Arduino. The problem is there that Arduino is not intended for being 24 hours per day, 7 days per week. So still we need to have, let's say, industrial Arduino, but the importance of things, the importance of intelligence at the edges is in this picture. You see a lot of things around a good network. How many things? Well, there are a lot of predictions. They say 50 billions of things. I think Cisco was saying 50 billions of things. I don't have an answer. I think it will be a huge amount of things. The important thing is that the infrastructure should be able to support the communication of this smart thing. I don't know if you had the experience of going somewhere in your country and other countries and you have no connectivity. Now you get lost. So we need to support all this stuff with good connectivity. And the more the application is demanding, and the more you have to give the connectivity, the right connectivity. Think again to e-health. What happens if you have an e-health application on a patient and he goes in an area in which there is no good connectivity? You should force him not to go there, probably. So you see, there are relationships. What kind of things you can see? And you see also the increasing complexity of the scenario. Well, there are passive things, essentially a tag, an address, or you can have autonomous things like a cleaning robot, you know, the Roomba that is going around your home and is cleaning up independently. He knows a little bit of the environment. So there is from a very stupid things, an address, to very complicated, robotic, and very intelligent things. So you see, you can cover all this kind of stuff. Sensor, an example in e-health. Why e-health? Because it's a very challenging environment in which you have a lot of constraints. You have policy constraints, and you have also technical constraints. But you see, essentially, I would say in Italy, we are trying to put in place applications that would release people from being in the hospitals and to be monitored at home. Why? Because I think 80% of the regional budget in the Italian region is devoted to health. It's a huge amount of money. If we can make with ICT, with, as you call it, TIC, if we can make saving, it would be a huge amount of money. So maybe many operators, many companies are interested in e-health for these reasons. The problem is that you have a lot of laws. Yesterday we were talking about teleworking, and there is the equivalent in e-health, telesurgery or whatever. But there are also policy. In Italy, a doctor, a medical doctor, has to touch the patient. He is responsible for touching him, to visit. What happens with the tele something in medicine? They are not going to accept that because there are a lot of implications. My wife is a medical doctor. If a patient calls her and there is the answering machine, the call is assumed to be taken care of. If the patient dies, my wife is responsible. What happens if you lose connectivity with this guy? A doctor will say, oh, I'm not going to work with telehealth or whatever. So we need to understand also the policy and the social issue related to this. Now, maybe with an example, you can get better this picture. In Venice, there is a statue and in a square. And there is an application. When people are passing by, this statue needs to be refurbished, to be polished because it's a little bit damaged. And there is this application. When people cross by the statue sends a message to the person and say, why don't you help me? Why don't give him €1, 50 cents, in order to get together the money to help me? What I'm trying to say, you can represent in the cloud almost everything, logical concept or physical things. And when you put the stuff on the cloud, you immediately make them programmable if you provide interfaces. So you see, you can represent any, let's say, Venetian masterpiece in the cloud, and then you can create services. You want to see this masterpiece, these are the time schedule. Do you want to have a person that is explaining you what is that? We can arrange for that. So as soon as you represent in the cloud a thing, that thing can become a service. And if you provide APIs, you can program that stuff. Think to this simple concept. We call it virtual continuum. You create a relationship between a thing and its representation in the web. And you can do a lot of things as soon as you have the right interfaces. So, dealing with billions of smart and independent things, well, they cannot be managed in the traditional manner, and so we discussed briefly about autonomics. And then there is the need to move toward zero configuration and autonomic systems. So you cannot afford to program all the stuff or to manage all the stuff. They have to be independent. Now we move to data. That is another important stuff. Cisco has provided, the vision of the future, the connectivity needs in a few years from now. There is something related to machine, and you see, they were saying for each month, each device, each mobile, machine-to-machine mobile device will produce 70 megabits per month. That means around 27 bytes per second. And in the future, in 2019, it will be 141 bytes per second. So each device will produce that amount, more or less, of data. So what is going to happen there? So there is a relationship, first of all, between a smart thing and me, you see. And there is also a functional relationship. I ask things to, let's say, Google or Facebook or other provider. So a lot of raw data can be transformed into information, but not by me, by the third parties. And they can know who is using the service or the thing, where this usage is taking place, when, what, and why. So all this information is, you can extract this information just analyzing the data. So what we can do with data? Generally speaking, they say, okay, things are producing a lot of information. This information can be stored in data stores, in data center, and then you have analytic engines that do try to extract information, and you can use this information to improve the services that you are providing. But that is just a part of the story. There is something more. There are other service providers that can receive those data, and maybe you don't know that. If you are a user of Firefox, I think there is an option there. And you see, when you are navigating in a specific website, you can open a screen and looking who is receiving the data that you are navigating, you are surfing in that specific data. I did that myself. I was just surfing on very reputed Italian newspapers, but my data was spread out to many companies I didn't know even they exist. So you see, smart city, you are providing your data. The smart city is doing some analytics, but what happens to your data? Who is taking there? Maybe they are profiling you. I'm not necessarily against profiles of users, but I want at least to receive back this information. Who is profiling me? For what reason? Why are they doing that? I want those data back, at least. That is my data. And when you are associating a person to terminals and to sensors, well, you are going to produce a huge amount of data. Imagine if here there are plenty of sensors, and they know that Roberto Minerva is here. Who is taking those data? What are they going to do? So you see, let's take the Cisco estimate of 15 billion of devices, around 2 megabytes per day. So they produce almost 90 petabytes of data per day. It's a huge amount of data. Who is going to use this data? Who is the owner of this data? And what they are going to do with this? Do you think it's fair that somebody else can track you in any things you are doing without giving you more than a free application? So there is a big attention. And with Internet of Things, this issue will be exacerbated a lot, because any single sensor will have an owner, and they can track you if you are using it. So vertical markets, e-health, logistic, transportation will produce a huge amount of data. Any application of those will produce data also about you. There is a privacy issue in how the data will be used. And by the way, IoT and big data will go hands in hands. That's inevitable. You will produce so many data in real time. You can process them in the back end. That will be the value of Internet of Things, if you want. But you have to ensure that that value is provided to the clients and to the citizen in a fair way. Okay, IoT and communication. So I'm supposed to talk a little bit about 5G in the remaining time and a few other things. So this picture comes from a discussion with a professor in the Polytechnic of Milano. You may know him, Maurizio Decina. We were saying the communication environment will be different. You know, in the past, the telecom operator was saying, I provide the services, I provide the communication, and the terminal is very simple. It's not anymore like that, for two reasons. The personal device and, let's say, the sensor in the environment are very powerful. And they have also small range communication. And probably applications will use small range communication more than, let's say, 4G, 3G, and 5G, and whatever. So this is a change in how services have to be operated. Networking is still a problem. A lot of applications developed for Internet of Things are not too much aware of what the network is providing. So you have a lot of issues. They consume power uselessly, but they are improving. So the point here in this picture is that the intelligence will reside on the terminals and will reside on the cloud. The network, we call the intelligent network, the smart network, it will just be a pipe. If the network is a pipe, it will generate few revenues. If they generate a small amount of revenue, your investment will be according to the revenue you are forecasting. So you see, there is a problem in this part of the investment. So that is something that is important. But there is also another aspect. I mentioned it to you that there are boards with Wi-Fi capabilities for €2 now. So that means that anything will be a node. Potentially, it will be a node. You can imagine toys that will be connected. Already there is Lego or something, Mindstorm and things like that. But anything could be connected. And so you can also imagine that there will be three things in one thing: communication capabilities, processing capabilities, and storage capabilities. Now, assume here probably we are 150 people. We have 150 devices with a lot of communication capabilities, a lot of processing, a lot of storage. Now, try to think of what kind of application we can create. It's a small data center, if you want, with a lot of connectivity. And this part is not taken care of. These possibilities are not taken care of because people and industries and enterprises are focusing in moving everything on the cloud because they own the cloud. But with software, with peer-to-peer, you can build, let's say, more fair applications that are using the resources, the local resources. So I think that will be another challenge. And this trend of having a lot of processing, communication, and storage capability is an important one. Now, it's an important capability, but you don't know how things will work together. We made an experimentation in Italy. I live in Turin. By the way, it's the city in which Quadraro will be playing soccer in the city theme. And we wanted to send a message to Venice. It's called the Padang Valley, no mountains for 500 kilometers, highly densely populated. And we made some simulation. We can send a message from one phone to another equipment, and we can send messages from Turin to Venice without using a public network. But that costs you a lot of software, a lot of availability of resources, people that do allow you to allow your software. Now, 5G. If you want to know more on 5G in general, I would refer to you to a nice white paper that the Next Generation Mobile Forum has provided. Is, let's say, 50 pages paper, and they do explain the approach that operators want to have with 5G. Essentially, they want to select the right technology in order to satisfy a number of application domains. One of these domains is Internet of Things. They have then general requirements. They want to have a round trip answer or less than 10 milliseconds. So if you have visors, there was an example from Vodafone. If you are watching reality with sunglasses and they throw to you a ball with 10 milliseconds of retard, you can catch the ball when they throw it, and you don't see the ball that has been sent to you. So the idea here is to have a very strong software infrastructure, virtualizing the resources, and trying to build, they call it a slice of network that is specially designed for that kind of applications. So you see, software-defined networks, I don't know if you are familiar to this, virtualization and Internet of Things can work together in order to create a slice that will accommodate the needs of different applications in the field of Internet of Things. But from my perspective, Internet of Things is so complicated that probably you need more than one slice. E-health communication is one thing, and I don't know, monitoring certain area, rural areas is another thing. You have different requirements in terms of delay, jitter, and things like this. But what is important here is the layering that 5G is starting to consider. You see, you have resources, you virtualize the resources, and you create an infrastructure for supporting specific application. Then through application programming interfaces, you allow third-party developers, end users to develop services in this infrastructure. I don't know if you are familiar with the end-to-end principle of Internet. They were stating many, many years ago that you shouldn't put in the network what can be done better at the edges. So Internet is a representation of this. We operators are saying exactly the opposite. We want to have a very complicated, very rich network. So we are providing a lot of capabilities in our network, but actually not too many people are using through APIs. So we need to select what kind of capabilities the network should be supporting. The only one, the important one that I found out for Internet of Things is the model that you know as publish, subscribe. One object is publishing its interface and say there are a lot of people that could be interested in receiving my events, and the subscribers will subscribe to the services that that object is providing. So if you want to implement that at the edges, you waste a number of network resources. Probably this is a functionality that 5G could implement it directly in the network. There are many protocols, MTTQ and the other protocols are adopting this kind of approach. There is also something else here behind the communication paradigm. If you think to the success of Facebook and Google, they are using client-server in two ways, from a technical perspective, but also as a business model. So they started being the server, and now they are also the client with Android and other stuff. So this kind of model, this kind of paradigm could be also important to change the structure of the market. So you see, technology could be neutral, but could be also strongly oriented to disrupt some market or some position in the world. Okay, so takeaway on telecommunication. We need to understand as operator the fundamental role of terminal and devices. They are the most important things. The intelligence is at the edge, and we have to put in the network only valuable functions. And 5G will be an enabler of this possibility. Okay, now a few remarks. One first remark is, what platform for IoT networks? If you look around, you don't find any single platform. You don't find a standardized platform. There is an attempt called one machine to machine in order to try to provide a standardized platform, but is an undergoing effort. What we see here is the need to have a number of different sensors, but we don't want to force sensors to be aligned to a specific protocol. So we need to take the technologies and the solution of the technology as they are, and we need to create a sort of, let's say, interworking level in order to allow the sensor to speak their natural language, so to speak. When we uniform these devices, we can then use an application development environment in order to allow the creation of applications. So you see many different kind of sensors, a way for integrating these different capabilities, a way for creating services, general functionalities and things like this, and then application on top of this. If you look around, you will find a number of software platforms like this, but they are still proprietary. Samsung is coming out with its own one. Brillo from Google is another one. And any single big player is coming out with its own solution. Why? Because they want to repeat what is happening with the mobile market. A very few number of operating systems, closed operating systems, even if they are based on Linux. And having this ecosystem in your hands is providing to you a lot of power. Dealing with data in a fair way, we need to understand how to anonymize data, how to protect the data of the user, and then many, many interoperability issues. Software, protocol interoperability, data. We saw a lot of things related to data. Okay, then there are business issues, but probably that will be for another, for another presentation. Thank you.